Hello, this is Aditi Thakur from IIPS JVV Indore. In this video, I am telling you about some numericals of numerical analysis and design. The first numerical is the population of a city in a census taken once in 10 years is given here. We have to estimate the population in year 1925, 1975 and 1984. Here we have given the tabulated data in which year and corresponding population in thousands is given. So for the solution, firstly we create a table in which in first column we write all the values of year. In next column we write the corresponding values of population and find the difference between them by using the forward difference operator. Here the number of data given is 7, therefore the difference operator will convert this up to 6 times. So firstly when we differentiate it, that is the value of del f will be calculated as the value of forward value minus the present value. That is 42 minus 35 is taken as 7. The next 58 minus 42 is taken as 16, 84 minus 58 is taken as 26 and so on. Similarly, del square f can be calculated as taking the difference of the consecutive values of del f. That is, first value will be calculated as 16 minus 7, that is 9. Next is 26 minus 16, that is 10 and so on. Similarly, del cube f will be calculated as taking the difference of consecuting values of del square f. That is 10 minus 1, 10 minus 9 is 1, 10 minus 10 is 0 and so on. Similarly, by taking the difference of previous difference operator, we will converge this up to del to the power 6f, that is 273. Now, using the Newton-Gregory's equation, that is f of x is equals to f1 plus del of f1 x minus x1 divided by h plus del square f1 x minus x1 into x minus x2 divided by 2h square. On solving this, we will get f1 plus del f1 u plus del square f1 u into u minus 1 whole divided by 2. Here we have given that first year is 1921. So x1 is 1921 and difference between the years is 10, that is 1931 minus 1921 is 10, therefore the value of h is 10. Now we have to find the value, that is population in year 1925. So x is 1925. Now the value of u is 0.04. Since x minus x1 is equals to uh plus x, putting values of x, x1 and h, we get the u as 0.04. So f of 1925 is equals to 35 plus 7 into 0.4 plus 9 into 0.4 into 0.6. So the population in year 1925 is 36.7. The next year which is given, that is 1975. Since 1975 is located at the end, so we will use here the backward difference formula. That is f of x is equals to f7 plus backward difference operator, which we call as nabla f7 x minus x7 upon my h plus nabla square f7 x minus x7 x minus x6 whole upon 2h square. On calculating this, we get f of x is equals to f7 plus nabla f7 plus nabla square f7 u into u plus 1 whole divided by 2. Here UH is equals to x plus 7. So U is equals to 1975 minus 1981 whole divided by 10. So we get the value of U as minus 0.6. Now putting the values of U, H, X7 in the above formula, we get f of 1975 is equals to 220 plus 100 into minus 0.6 plus 100 by 2 into minus 0.6 into minus 0.6 plus 1 plus 136 by 6 into minus 0.6 into minus 0.6 plus 1 into minus 0.6 plus 2. On solving this, we get the population in year 1975 as 124.48. Now, the last year, that is 1984. It is outside the table of values. Thus, we can't interpolate. So if we assume a similar train is followed outside also, then in case of 1985 we can make this assumption that we get u is equals to 1985 minus 1981 upon 10, that is it equals to 0.4. So again putting the values of x, u and h, we get f of 1985 as 432.486. Now, the next question is, we have to solve the given equations using Gauss-Jordan method. In Gauss-Jordan method, we make all the terms except the diagonal terms as 0 and directly solve the equation. So here the equation are 2x1 plus 4x2 plus 2x3 is equals to 15. It is equation 1. The next is 2x1 plus x2 plus 2x3 is equals to minus 5. It is equation 2. And the last is 4x1 plus x2 minus 2x3 is equals to 0. This is equation 3rd. So, the solution of these equations using Gauss-Jordan method. Firstly, we write all the coefficients of x1, x2 and x3 in form of matrix. So, here is the matrix. Now, we perform some interchanging operations on them to make the terms of matrix 0 except the terms of diagonal. First, we have to make the term R2 and R3 as 0. So we apply on R2, that is R2 minus R1 into 2 by 4, and on R3 we apply as R3 minus R1 into 2 by 4. On applying this formula, we get the values in row 2 and row 3 as 0. Similarly, on applying the sum formulas on other terms, we get whole the term as 0. Now, putting these values in form of equation, we get 36x1 plus 0x2 plus 0x3 is equals to minus 110. So, x1 is equals to minus 110 upon 36, that is minus 55 by 18. Next equation is 0x1 plus 12x2 plus 0x3 is equals to 80. So, x2 is equals to 80 by 12, that is 20 by 3. The last equation is 0x1 plus 0x2 plus 72x3 is equals to minus 200. So, x3 is equals to minus 200 by 72, that is x3 is equals to minus 25 by 25 by 9. Sorry. I hope you understand the method of interpolate and Gauss-Jordan. Thank you.